call a function and it returns you back an object, or C++ and it returns you back an instance of an object, you shouldn't necessarily know that you have to call the destructor on that object. It's part of the style guidelines, and it's heavily enforced in Objective-C, and you'll see how that works. So you can return objects that you own as long as you release them later. So if you allocate something in one of your classes and you return it, that's cool. If when your class goes away, gets deallocated, you get rid of that memory yourself. It should not be the owner's, it should not be the caller's responsibility to release your memory. You should be handling that. So if you have an instance variable that's an object, return it. That's fine. Why is this bad? Why is returning a copy of the instance variable bad? Yes, why? Because we called copy, and what does copy do? Yes, sets it to 1, but there's a more important thing that it's doing. First, allocating memory, copying data into it, setting the ref count, returning. Allocating memory is the important part. So, calling copy is you're allocating memory, and then you're returning back that newly allocated memory. You're assuming that your caller is going to free up or release that memory, which we don't want to do. We want to be responsible for cleaning up after ourselves. So, here's a real typical example, and where we start running into a problem. So, let's say we made a class method called string with string. We pass it a string, and our goal is to return back a copy of this string that was passed in. So, allocate, initialize it with the string that was passed in, and return it. What's wrong with that? Allocated the memory. We haven't said anything about releasing. We're assuming that the caller is releasing that. That's bad. So, what do we do about that? Well, all right, so we allocate the string, and then we release it, and then we return back the new string. Yeah.
You laugh, but why is it that you're laughing? It's an important point.
Well, the block of memory has already been released. You're just returning a memory that has no reference to.
Why has it already been released? Which does what? Decrements the reference counter. So instead of thinking of retain and release, think about in terms of the reference counter. Okay? So if we return something with a ref count that's higher than 1, and we're expecting the person above us to do a whole bunch of releases to get it back down to 0, that's really bad style, and you'll end up leaking memory all over the place. So enter auto release. Okay, so this is what people have the most conceptual trouble with, and I'll see if I can explain this clearly enough so that it makes sense. It may not until you do the next lab and the lab after, which has you practice this. Here's the idea. So when you allocate or copy or retain something, but you want to be responsible for the memory management, but you don't want to have to explicitly release it or explicitly deallocate it, because we're caught in a catch-22, right? We can't deallocate it early, and if we don't provide a delete this string method that we're forcing the user to call, then we're caught. We don't have control over it anymore. So here's what we do. We relinquish control to the auto-release pool. It's a pool of memory that gets created, and when your program, every time your program gets an event, whether it's starting up or it starts receiving keyboard events or mouse gesture events or drawing events, every time you get one of those events, it creates a pool. Every time you add something to the auto release pool, it goes in, it stays there until that event is done, and you come back out of your event loop. And this will make more sense later on when we start talking more about views and events. But the basic idea is when you get an event, you create a pool, objects that you don't want to be responsible for anymore, you can put into that pool. When you come out, when you finish that event, that pool dumps all of those objects. Yes?
What if we want it to last longer?
That's an excellent question. Hold that for one slide. Yes?
Is it possible to create a string without allocating space for it first?
How?
I don't know. So you always have to allocate before you can like create a string.
Yes. I mean, it's just like making an instance in C++, right? You always have to allocate some space for it, and then you can initialize the values that are the instance variables that are within it.
Actually, that's only parsing, Joe. We need to take a break. I think the thing's going to run out.
Okay.
But this string with string method, it seems really silly, but this actually is a real method that's already defined in a string. We're just kind of defining it here. You'll notice that this is a class method, so there's a lot of these what we call convenience methods, where it will create an object for you, but it'll abstract away the allocated pattern. But the way it does that, so that way that the memory management is balanced, is it has to do an auto release. So this is effectively how string with string is actually written. So you don't explicitly allocate memory, but the method itself actually does, and then it auto releases it, so that way it's manages memory properly.
Okay, you want to switch?
Yeah, let's switch
tapes. Okay. Great question, by the way. That's what screen captures for. Okay, so the question was, how do we know that this, when we call this auto release, that it's not like the regular release and doesn't get dumped right away by the time we get here or the caller gets it? It's
Here, advance the slide. Last slide, a couple slides.
okay. So hold that thought for just a second. So this is the part that trips everybody up, and this is the part that I hated when I first learned Objective-C. Auto release releases it sometime later. Super fuzzy term is not used a lot in computer science. So that you can return this string, and it won't have been deallocated ahead of time, but you're not responsible for releasing it later. You're giving up responsibility for releasing it to the auto release pool. So how does it work? Well, you don't really need to know about that. You don't need to understand how it's actually built. And we can give you all of the specifics about the pools created when you get an event, and when you call auto release, it throws objects in the pool, and then they don't actually get released until your code is finished with that event and you go all the way back out of your handler. Let me see if I can answer your question like this. Here's the rule of thumb. If you need something later, if you're not calling alloc or you're not calling copy, and you're using one of these convenience methods like init string with string, and you actually need a copy of it, and you need to hang on to a copy of it after this event's been processed and later on down the road, you call retain on it. Okay? So, if you need it, retain it. Make sure that you balance that with the release sometime later. And we'll talk about a good place to do that in a few slides. But if you need it, retain it. Make sure that you release it sometime later. If you don't need it anymore, forget about it. You don't have to worry about it. It's in the pool. When the event's done, it's going to be released for you. So you don't have to worry about the memory management there. Having too many retains and too many balanced with too many releases is not super optimal, but it's okay especially when you're first starting out, if you over retain things. So if you have a call to an init, like an init string with string, you have a retain there, and then above that you got to retain, and above that you got to retain. As long as they're balanced out, you're okay. You're not leaking memory. You shouldn't run out of memory, but make sure that they're always balanced. When in doubt, retain and then later release. If you have too few retains, though, you'll start running into problems. If you have that string allocated with init string with string, and then you use it, like you stick it in a pointer, you stick a pointer to it in your in one of your objects, and then you use it later on, you'll get an exception will be thrown, because that string's been put in the auto release pool. When the operating system is done with processing the event, it's going to release all of those objects that are in the auto release pool. This will become even far less magic with this lab on Thursday, because you'll be implementing an auto release pool. It's actually really easy, and you've already got the tools to do it, or you've already seen the tools to do it. So if it seems like magic and voodoo right now, it's totally understandable. That's the way it was for me too, and I hated the idea of sometime later. But it will make a lot more sense as we start talking, as we get a little bit deeper into the operating system and how the operating system works and events are handled. Okay? Rules of thumb. If you need it, retain it. Make sure that you pair it with a release later. If you need to use it once and you don't need, like you need to print it out and you don't need it again, leave it alone. It's going to get auto-released. So when you add an element, when you add an object to a collection, like an array or a set or a dictionary, the collection increases the object's retained count by 1. So you can create an object. Let's say you allocate and initialize an object, and then you put it in a set. What's its retained count? 2. Why?
Because we initialized it.
Not initialized it.
We allocated.
Allocated it. We allocated an object. That gets a ref count of 1. We added it to the collection. That increases its ref count. So now its ref count is 2. Every object that you add to a collection gets its ref count increased by 1. When you deallocate the collection, it goes through and decrements the ref count on every single one of the objects. Why do this? What's the method of madness here for doing this? Any ideas? Throw them out. Yeah.
So when you're iterating through collection, you have to know what's
there's actually a better, I understand what you're saying, but there's actually a more important reason for this.
When you're getting an object from an array, you know that it has memory. You know that you are getting an object that has memory.
Yes. So when you add objects to a collection, if you're going to say iterate over them, enumerate over the objects, or you're going to use objects in that collection guarantees that unless you've done something really funky, those objects are going to still be live. Even if you release them, they'll still be live in the collection. Then, to make sure that it cleans up after itself, it goes through and subtracts 1 from the reference count. So, you allocate an object, you add it to a set, its ref count is no, 2. You delete the set. What's its ref count? Hasn't gone away. What do you need? Release. Good. So NS objects have got a method that you can override. It's the dealloc method. It is it's called automatically as soon as a reference count hits